Okay, we're in section 38, and we're going to be doing, at least in Math 100, there's two types of conic sections that we're going to be dealing with, and that's going to be the parabola and the circle. At the Math 100 level, parabolas are going to look like cups, either opening upward or opening downward, and we'll go through it in detail. All right, now the detail that we're going to get from you is that, the shape of it, I'll go to whiteboard later, something about key characteristics. Well, key characteristics for most people are going to be x-intercepts, if they're easy to find. A y-intercept, well, at the Math 100 level, that's always easy to find. And the other thing that's really easy to find at Math 100 level is what's called the vertex. Now, if this opens upwards, the vertex will be a minimal point. If it opens downward, and we'll see examples like that, it would be a maximal point on the curve. All right. So we're going to talk about what a parabola looks like in a generalized way, and then we'll talk through the process that we'd like you to go through. We don't want to make anything too difficult. We want to make sure that this proceeds forward pretty smoothly. All right. So let me point out what I mean by that. We're looking for really nice points. Let me point out again, y-intercept, generally easy to get. Next thing easy to get would be the vertex. If x-intercepts easy to get, we're going to get them. All right. We'll talk about how to get these things as I go to the whiteboard later. All right. We'll give you a formula and then we'll go to examples. All right. Let me go to the whiteboard. And as I go to the whiteboard, we'll talk about the features we're looking at. All right. So give me 1 second. Okay, we're on the whiteboard now. And what am I going to do here? Well, I'm looking at it. I'm looking at the parabola. So my claim over here is, just looking at it, I do see something here. I want to claim what I'm seeing over here. I'm seeing something that looks like a cup. I'll put this over here. Now, this is a partial picture. What I mean by that is it can't give you the full picture. This goes on forever in that direction. This is somewhat reminiscent of what we do with lines, that they kept going on and on and on. Keeps going up. All right, keeps going up. Now, what else do I notice about this thing? And I'll point out what I'm noticing about it, that there's a dashed line given over here. And what do I notice about the dashed line? I notice that what's on left, what's on right appear to be symmetric. So this line over here is called an axis of symmetry. That's abbreviated AOS, right? There's other things I noticed along this curve. I notice there's points here. Now I'm going to look at my picture. I'm going to write those points down for you. So this point over here is an x-intercept. It looks pretty easy by inspection. It looks like 1, 0. This one also looks easy. By inspection, it looks like -3, 0. This one looks really easy. What I notice about over there? Well, it looks like 0, -3. What does this point look like? Well, this one's a little more difficult. If I looked at it, I would say it looks like -1, -4. Now let's look at the equation and talk about why this is so easy to deal with, right? Generally speaking, these problems will be very simple to do. You get y equals x squared plus 2x minus 3. What I would recommend to do, if you see an equation like this and they ask you to graph it, what I would recommend to do, if it's easy, factor it. If it's not easy, do not factor it. Let's see if we can factor this guy. Y equals x and x. Remember, if it's not easy, I'm not going to do it. 3 and 1. Let's see, plus 3 minus 1. I want to make sure that works. X times x is x squared. Plus 3 minus 1 is plus 2x. That worked, and you do get -3. And then what I do is I write down what's called easy points. Easy points. And again, I'm just verifying. One of the easiest points you could get is the y-intercept. All right. How do you get a y-intercept? Set x equal to 0, and that'll be a point. So 0, comma. What's nice about this? Generally speaking, it's easy. 0, 0, -3. That's the y-intercept. All right. I want to verify that that's written over there. I'm seeing that in my picture. All right, let's go to the next thing up. Easy, x-intercepts. What's an x-intercept? You know, you got to set y equal to 0. Well, if you do that, what do you notice? If y is 0, you're trying to figure out if y is 0, it's a zero product rule. When do the factors become 0? Well, at 1 and at -3. So I'll put this down for you. At 1 and at -3. All right, let's go over here and make sure you know what I'm looking at. I'm looking at this picture over here. So I got this one over there, 1, 0, and I got this one over here. All right. Now I got to be honest with you, the vertex looks like it might be tough to come up with, but I've got 3 points at this stage. What I want to claim about the vertex though, and this is important, if you look at the picture, what do I notice? I notice there's a line that has to be symmetric with respect to the x-intercepts. So if you look at the x-intercepts, one's here, one's there. Well, the distance here is 4 units. So really, it's got to be 2 units on each side to be in the center, right? So there's 2 units here, 2 units there. So what is this line then? This line over here is x equals -1. I'm going to write that down now for you. So the axis symmetry is x equals -1. All right. I'm going to write that down over here now. And let me point out what I mean by that. The axis symmetry is dead center between those x-intercepts. So the axis symmetry, AOS, has to be x equals -1. Let me point out what I mean by that. If you look at these points over here, dead center point over here would be, well, you add them together, divide by 2. So it's going to be 1 plus -3, which is -2. -2 divided by 2 is -1. That's what the x is. And of course, the 0 plus 0 is 0. 0 divided by 2 is going to be 0. Let's go back up here. I want to point out what I'm talking about over here. Whoops, sorry about this. We're talking about this point over here now. Whoops. We're talking about this point over here. Right there. That's where the axis symmetry goes through. The vertex must lie on the axis of symmetry. It must lie on the axis of symmetry. Whoops, I think I made a little tiny error over here. Let me get my, sorry about that. I'll push this over here now. Okay, so the vertex must lie on the axis of symmetry. If that's true, what's the x? It must be -1. Well, you know what we got to do now? We have to plug it in. Someone says, where do you plug it in? The original equation. So let's do that. So what's y going to be equal to? Well, I'm going to parenthesize the variable and plug it in. And what do you get there? 1 minus 2 minus 3. And you get 1 minus 2 is -1, -1 minus 3 is -4. That's my vertex. Does it match up with the picture? Yep, it matches up with the picture beautifully. All right. Okay, so my claim over here is that, you know, this is not always possible for me, that things are always going to work out so nicely, but I got to be honest with you, for the most part, they work out nicely. So what I want to talk about, the next page, I want to talk about a formula. All right, I want to talk about a formula. And the formula I want to talk about is the formula for the vertex. And they give it to me, it's right over here. And this is with the understanding that you got an equation where the quadratic can be y equals ax squared plus bx plus c. If I have an equation of that form, the vertex will look just like this, with the understanding the y is actually a function of x. All right, I'm going to explain that to you. However, if you're not satisfied with the explanation, okay, sorry about that. I had a call come in, but I'll take care of that later. So if you're not satisfied with the explanation, that's fine too. What I would recommend you do is think about it, all right? And if you're thinking about it, you still can't get it, you're gonna have to memorize this, I'm going to tell you where it comes from, though. If we look at the form f of x equals ax squared plus bx plus c, the only thing I look for is the x-intercepts. And why is that? The axis symmetry has to go dead center between that. So what do I do for x-intercepts? I set f of x equal to 0. And this is the explanation where this formula is coming from. How do I solve that? Well, x equals minus b plus or minus, this could be b squared minus 4ac over twice a. All right, there's two x-intercepts now. I'll write them down for you. Minus b plus, wow, it's really nasty, isn't it? Comma 0, that's 1. What's the other one going to be? Minus b minus, this is really going to get crazy looking, isn't it? We want the midpoint. All right, no matter how bad these things look, they have a midpoint. 0. How'd I do that? Add 0 plus 0 and divide by 2. Here comes the tough part. I need to take this and this and add them together. And what would you get? Well, you would get minus 2b over 2a. And why is that? Those radicals disappear. And what does this give me? Minus b over a. What do we have to do? Divide through by 2. Well, if you divide through, what do you get? Minus b over 2a. So the only thing I really do now know is I got some x-intercepts, and then there's a line of symmetry between those two lines. And what is the line? X equals minus b over 2a. Where's the vertex? It must be here somewhere. So I'll put that, when I say here, along this line somewhere, what's it going to be? Minus b over 2a, and then f of minus b over 2a. Now, granted, I realize it's a lot of work, but the bottom line is really not that bad. We'll go through examples, by the way. What I mean by that, we will hammer across this formula. This is a formula. We'll do examples next. Thank you for paying attention, and we'll do examples, all right? Thank you.